Alright, I was cut off because of my phone, but if we calculate the initial potential, you're gonna get 13,720. And that's equal to the initial potential. So how much energy they have up here. And then if you calculate this, which is the amount of kinetic energy they have at the bottom of the hill, it is 7,875. Yep, joules. Alright, so this law is saying that these should be equal to each other, but they're not. And that lost energy is due to friction. So it's going to be lost due to friction. So energy lost due to friction is equal to this number minus this number, right? The difference between them. And that's 5,845. So this number minus that number is equal to 5,845. They should have the exact same energy here as here, but they don't due to friction. So that's how we get that number. And that's your lost energy due to friction. And then the next part of the question is if the skier continues after the bottom of the hill. So if they continue right here, and now we're going from right this way, 30 meters. So now the skier is starting down here with an initial velocity of 15 meters per second, a final velocity of 0. That is because if the skier continues after the hill and eventually stop after 30 meters, find the friction force. So we're looking for force of friction. If the skier stops right here, that's a stop sign, and they have 15 meters per, their velocity is 15 meters per second to begin with. So how I tackled this problem was by saying that they have right here, they've got 7,875 joules of kinetic energy. So right, we found that his final kinetic energy is equal to that much. So right here is that much kinetic energy. And then he goes to a completely stopping point. So he's not moving, he has no kinetic energy. So we're going to 0 joules. Therefore, change in kinetic is equal to negative 7,875. At this point, I wasn't really sure where I was going. I was just working with what I had, and I got an idea. And that was work is equal to force times distance. In this case, it's force of friction, because the work being done is to stop the skier. So then all that we have left is to plug it, right? We know our distance. Now we know change in kinetic, and change in kinetic, not only is it equal to negative 7,000, it's also equal to work. So we can plug that in right here. negative 7,875. And then we want to find the force that does this stopping, which in our case is friction. And then we know the distance. It goes from 0 to 30 meters. So our distance is going to be 30 meters. Yeah. So then what we do is we divide by 30 by both sides. So that cancels on this side. And then over here we divide that and we find our answer. So force of friction is equal to this divided by that, and we know it's going to be negative. And then I did all my calculator work on my paper. So I know that 7,875 divided by 30 is 262.5. 262.5. Now, working through this, these are joules and these are meters. So we're going to have joules over meters. And after a little bit of work on paper, I got to this because I looked up what joules stood for, and I did some canceling, and I found out that that also means, so joules over meter is equal to kilograms times meters over seconds squared. So joules over meter is equal to kilograms times meters over seconds squared, which happens to be the unit for force. So my units check out, and that gives me much more confidence in my answer. So that's what I got. The amount of force that was being applied onto the skier due to friction was 262.5 joules per meter, or kilograms times meters over seconds squared. And it's negative because it's not in the direction that he's going. So that's my answer and my explanation. Yeah, thank you very much.